Hi everyone, this is Mrs. GA, and today we're going to do coordinate proofs using distance formula. So we're going to be talking about different ways to prove that shapes are different types of quadrilaterals, and today we're going to be using the distance formula to do this. So example 1 says, how could you use the distance formula to prove or disprove that the quadrilateral with vertices A, B, C, D as listed is a parallelogram? So we know that one of the properties of parallelograms is that opposite sides are congruent. So we can use the distance formula to show that both pairs of opposite sides are congruent. So it may help for us to draw a little sketch just so we can determine which the segments that need to be congruent. So we need to show that AB is congruent to CD, and we need to show that BC is congruent to AD. And of course, the distance formula, we'll write it here. Remember, it's the difference in x values squared plus the difference in y values squared, and then you take the square root of all of that. So let's start by finding the length of segment AB. Okay, so if I'm using AB, we could do x2 minus x1, so let's say 4 minus 3 squared plus y2 minus y1, 4 minus 1 squared. And then we're going to simplify from here. So this gives us 1 squared plus 3 squared. So this ends up being the square root of 10. Okay, so that's the length of AB. Okay, let's see if it's the same for CD. So we know for CD we're using these two coordinates. So here we'll do x2 minus x1. So remember, when I'm subtracting a negative, I'm actually adding, and then we'll square it. And then here, negative 1 minus 2 squared. Remember, we're always simplifying inside the parentheses first and then squaring that number. So be careful here, because negative 1 squared does become positive 1. Negative 3 squared becomes positive 9. So we end up with square root of 10 as well. So since the lengths of AB and CD are both square root of 10, we know that AB is congruent to CD. However, for it to be a parallelogram, we do need to prove that both pairs of opposite sides are congruent. So why don't you take a moment, pause the video, and see if you can prove this next statement, that BC is congruent to AD. So again, this is what we've done so far. See if you can prove the rest. And we'll check our answers in just a few seconds. Okay, so go ahead and check your answers here. So here you can see I used distance formula to find the length of BC, which is the square root of 29. And I did the same with AD, which is also square root of 29. So we have just shown that BC is congruent to AD, which proves that ABCD is in fact a parallelogram. Okay, let's have a look here at example 2. A parallelogram has vertices J, K, L, M, as stated here. Use the diagonals in a coordinate proof to decide whether it is a rectangle, a rhombus, or a square. It may be neither, or it may be more than one of these. So before we actually start doing this, let's have a strategy. So what do we know about the diagonals of a rectangle? We know that the diagonals of a rectangle are congruent. And then what do we know about the diagonals of a rhombus? We know that the diagonals of a rhombus are perpendicular. So we can show that the diagonals are congruent using the distance formula. We can show that the diagonals are perpendicular by comparing the slopes. And we can show that it's a square if it is both of these things. Okay, let's start by plotting these four coordinates just so we can see what our parallelogram looks like. Notice that it does state that it is a parallelogram, so that's a good starting place for us. So J is here at 0, -4. K is at 5, -1. L is at 4, 4. And M is at -1, 1. Okay, so the two diagonals that we are working with would be JL and MK. So let's start by checking to see if this shape is a rectangle. And again, it's a rectangle if the diagonals are congruent. So let's find the distance of JL. So I'll do the distance formula again. So we can do 0 minus 4 squared plus -4 minus 4 squared. Here, it'll be -4 squared plus -8 squared. So JL will be the square root of 80. And just to be thorough and just for the extra practice, let's talk about how we can simplify this square root. So remember, one way to simplify is to simply do a factor tree until you come up with prime factors. So we do 8 times 10. 2 times 4, 2 times 5. I'm circling my prime numbers. And then we have 2 times 2. So remember, we could say square root of 80 is the same as square root of 2 times 2 times 2 times 2 times 5. You can list out your prime numbers. And then for each pair of numbers, one escapes. So we end up with 4 root 5 because 2 times 2 is 4. So this is the length of JL. And now we have to see if that is the same as our other diagonal, which is MK. So let's do distance formula again. So here we have the square root of, let's do 5 plus 1 is 5 minus -1 squared plus -1 minus 1 squared. So here we'll have 6 squared plus -2 squared. So this gives us the square root of 40. So again, we can see that they're not congruent, but just for the extra practice, let's simplify this. Another way you can simplify square roots is by actually looking for prime numbers when you're factoring. So I know that 40 is 4 times 10, and I know that 4 is a prime number. The square root of 4 is 2. So I can simplify it straight from there, and I could say it's 2 root 10. So we see that JL is not congruent to MK. So that means that we can conclude that this is not a rectangle. And if it is not a rectangle, that means we can also conclude that it is not a square, because a square has to meet the requirements of both a rectangle and a rhombus. However, we could still show that this is a rhombus. So we're going to have to go back and now look at our diagonals again and determine whether or not they are perpendicular. Okay. So remember, the way that we show that two lines are perpendicular is if they have opposite reciprocal slopes. So here we could either use our picture to determine the slope just by looking at rise over run, but just for practice, let's do the distance formula or the slope formula. So let's start by finding the slope of JL. So remember, it's change in y over change in x. So we can do 4 minus negative 4. So 4 minus negative 4 over 4 minus 0. So this is 8 over 4, which is a slope of 2. And now let's find the slope of MK. So here we could do 1 minus negative 1. So 1 plus 1 over negative 1 minus 5. So this equals 2 over negative 6, which equals negative 1/3. So here I can see that the slopes are not opposite reciprocals, so therefore we can conclude that JL is not perpendicular to MK, so we would say that it is not a rhombus. All right, that is all for today's video. Thank you so much for watching.